Welcome to Chemical Equilibrium Lesson 2. The Rice Table. This table will be used for more complicated calculations. You will need this table to answer more difficult questions, so pay attention. If A and B is your reactants and C and D is your products in this chemical reaction, the table will look like this. The rice stands for reaction for R, initial quantity for I, change for C, and equilibrium quantity for E, as well as equilibrium concentration. Now, this table will be used for questions where you have an initial situation and then the reaction reaches equilibrium, and then you have to do some calculations around that. So, example 1. 1.4 moles of ammonia is introduced into a sealed 2 cubic decimeter reaction vessel. The ammonia decomposes when the temperature is increased to 600 Kelvin and reaches equilibrium as follows. So this is your chemical reaction. The ammonia is the reactant and the nitrogen and hydrogen that forms are the products. When the equilibrium mixture is analyzed, the concentration of ammonia is 0.3 moles per cubic decimeter. So that is what they give you. When this reaction is at equilibrium, the concentration ammonia is 0.3. And then the questions. Calculate the concentration of nitrogen and hydrogen in the equilibrium mixture. So let's just focus on that for now. The first thing to do is draw your rice table and put in your reaction. So the ammonia is your reactant, the nitrogen and hydrogen are the products. The initial quantity, that is the values that they give you in the question. 1.4 moles of ammonia is introduced into a sealed 2-liter reaction vessel. So 1.4 moles is put in at ammonia initial quantity. Now, do you agree? At the beginning of the reaction, there will only be reactants. When the reaction starts, then the products, nitrogen and hydrogen, will start to form. So in the beginning, there is no nitrogen and there is 0 hydrogen. And then another given in your question is that at equilibrium, the concentration of ammonia is 0.3 moles per cubic decimeter. That is what you get there. So the next step then is to see what they are asking. Calculate the concentration of nitrogen and hydrogen in the equilibrium mixture. So they want the concentration nitrogen and the concentration hydrogen. Now to get to that, you need the moles. To calculate concentration, you need moles divided by volume. And they give you the volume in the question, a 2 cubic decimeter reaction vessel. So you're going to use this equation at the end. Concentration is moles divided by volume. So the important thing now is you need the moles of nitrogen and the moles of hydrogen. So how are we going to get there? We can calculate the moles of ammonia because we have the concentration of ammonia. So if we have the concentration, we have the volume, now we can calculate the moles of ammonia. So this is how we're going to do it. Concentration is equal to moles divided by volume. So the concentration is 0.3 moles per cubic decimeter. And the volume is 2 cubic decimeter. That you get from your table and the question. So then the moles of ammonia is 0.6 moles. Now you go back to your table and you fill in the quantity that you just calculated. Now if you have the equilibrium quantity moles and you want the concentration of nitrogen and hydrogen in the equilibrium mixture. Now you can use your table to get to the blue needed values. Now remember your stoichiometric value. It's 2 moles of ammonia is going to 1 mole of nitrogen and 3 moles of hydrogen. So to get from 1.4 to 0.6, we're going to have to do minus 2x. To get from 0 to the equilibrium quantity, you have to add x. And to get from 0 to the wanted equilibrium quantity, you have to add 3x. Now, if you have this calculation, then you can do the math easily to determine x. So that's your next step. Calculate x. 1.4 moles, that's what you get there, minus 2x there equals 0.6 moles that you get there. So now it's just solving the equation, simple maths, to get to x is 0.4 moles. Now you can complete the table for nitrogen and hydrogen. Nitrogen is then 0.4 moles and hydrogen is 3 times 0.4. So that then gives you 1.2. And now if you just add up your table, you get to 0.4 moles and 1.2 moles. But that is not what was asked in the question. The question asked the equilibrium concentration of nitrogen and hydrogen. You now have the moles of nitrogen and the moles of hydrogen. So you can calculate the concentration by using your equation. Concentration is equal to moles divided by volume. So if you want to calculate the concentration nitrogen, you take the 0.4 mole divided by 2 cubic decimeters. That gives you 0.2 mole per cubic decimeter. And then for the concentration hydrogen, you do the same. The moles of hydrogen divided by the volume. 1.2 moles divided by 2 cubic decimeters is then 0.6 moles per cubic decimeter. And then you put those values back into your table and that's your final answer. Then part 2 of the question. Calculate the equilibrium constant for the reaction at 600 Kelvin. Now we talked about equilibrium constants in lesson 1. If you can't remember what equilibrium constant is, go and check that again. So, an equilibrium constant is the concentration of the product times the concentration of the product to the power of its stoichiometric value divided by the concentration of the reactants to that value. So for this specific reaction, that one that we are working with, the Kc would then be the concentration of nitrogen to the power of 1, because there's only a 1 there in front of the nitrogen, times the concentration of hydrogen to the power of 3, divided by the concentration of ammonia to the power of 2. Okay, now you have the concentration of ammonia and you just calculated the concentration of nitrogen and hydrogen. So now you can just add your values into your equation and do the maths. That would give you 0.2 to the power of 1, 0.6 to the power of 3, 0.3 to the power of 2, which then gives you 0.0432 divided by 0.09, and then Kc is 0.48. Thank you.